Hello. I wanted to take a minute to explain the difference between drives and writes in Neos and why you might care about that. Um, as far as I know, this isn't documented anywhere, and there are some cases where knowing the difference in behavior between the two becomes important. So, first, let me show you what I mean by a drive and a write. So, if we have two objects here, this blue, whatever that shape is going to be our target position, and we're going to move this red cube to that position. If you these references are to each object here. So if we just take the blue thing's position and we send that to the red cube's position, that is a drive. So this position is driving that position, and the logics just looks like a solid continuous connection. There's no events going on telling this that, checking did this position change and go and update that position. It's just a solid continuous connection. This position is setting that position. And I added a smooth transform to the cube just so you can see it moving. Otherwise, it would be stuck to the blue thing instantly, and you couldn't tell if I was cheating and had it parented or something. Now, if instead of making this direct connection, we wanted to write the position, again, this is the red cube, so we wanted to write something to its position. And let's say that we were just taking the position of the blue thing as the source. So, there's the source. We explicitly write that into the position of the cube. And writes don't happen continually. They happen when an impulse tells them to. So we need something to trigger this. Like, I could just okay. So this won't write that position in until I tell it to. You can see I can move the blue thing, and the cube doesn't follow it until I actually trigger the write with an impulse. Or, of course, that could happen on a timer. So, say once per second, we want the position to synchronize. Now, if I move the blue thing, once per second, it's taking the position of this blue target and writing it into the position of that cube. So that's a write as opposed to a drive. And the reason that you care about this is because drives like this are not synchronized over the network, because Neos assumes that this thing that's being driven can always be derived from its source. So it doesn't see any reason to explicitly synchronize this drive here, because it figures that each client can calculate that for themselves. Now, when I move the blue thing, that position is synchronized over the network. But this red cube there, that position is calculated by each client independently. It's not synchronized. And with a write, when you go and you write that value into the position, that will synchronize over the network. And most of the time, that doesn't matter. That's just transparent to you, because usually the assumption is correct that the driven value can be derived from other items which are synchronized, and you won't see any difference. But there are certain cases where if you use a drive with no rights, the the values can get out of sync between different users, and everyone will see things in a different position. So this smooth lerp node is where people most often discover the differences between drives and writes. So the smooth lerp node can be used to drive the position of the cube. Once I get the data type set up correctly. And I'm going to go and get rid of that smooth transform component so that it just moves there instantly. So if you take a smooth lerp and you tell this cube to go to a position, what will happen here is basically, let's see if I move it up one. So what's happening here, again, this is a drive. So when I change the position that is basically its target position here, this value here will synchronize between all the clients, and then each one will independently calculate that smooth motion to that target point. And if you are moving your object to like a global position, that is fine. Even if each client, maybe they start moving it at a slightly different time, or their frame rate is a little bit different, it doesn't matter because they're all moving it to the same target position, and all the users will see this cube move to that position. Now, it may look very, very slightly different for different people. Maybe for some users, the cube arrives at its target position just a little bit earlier or a little bit later, or it starts moving, at a different time. But it's converging, all the different clients are converging upon this solution, this target point. So even if there are some very slight differences in how they get there, it won't have any great impact on anything. Now, where you can run into a problem with drives and their lack of synchronization is if instead of moving to a global position, if, for example, I tell this cube to move up relative to itself, so there's like a feedback loop where it moves up and then it's at a new position, and it is moving relative to itself, so it moves up again and up again and up again, always relative to itself. That is like a feedback loop. And that works fine. You'll see the cube move up. But the problem with that feedback loop is that if you're using drives and you don't have any writes in here, there is nothing that gets synchronized between different clients. So with that feedback loop that you've created, everyone can see this thing end up at a completely different position, because there will be small differences in, timing or frame rate or something like that. And they'll get just a little bit off. And because there's no right here that gets synchronized, it's just driven values and derived from other values and no network traffic going on, for different users in the world, it will end up in a completely different position. So this little sphere there is a child of this cube. You see, if I take this cube, let's see, I made that not grabbable. If I move the cube around, you can see the sphere moves with it because it's a child of it. So if I take that sphere and I take its global position, so I'm getting the global position of that sphere, not the local position. And I give the cube here its target position through a smooth lerp of the position of this sphere, what will happen is this cube will be trying to move towards the sphere, but since the sphere is a child of it, the sphere is always a fixed distance away from it, so it will just keep moving and moving and moving in the direction of the sphere. Kind of like the carrot on the stick in front of the donkey. The donkey moves towards the carrot, but the carrot moves with the donkey, so it just keeps going forwards. I don't think donkeys are actually that stupid, but that's the classic example. So there's a sphere. We're taking its global position, and we're telling the cube to move to that position. One more time. Let's see if I have this right. So this sphere here is the target position. We're getting its global transform, and we're going to tell that's being used as a target for the smooth lerp, which smoothly moves it to that point, and we're going to drive the position of the cube. You can see the cube is trying to move to the sphere, but since the sphere is a child of it, it can't catch up. And this, I mean, obviously it does what we expect in that we see it moving. In fact, I can change its target and it'll keep moving towards the sphere. The problem with this is that since this is all drives, you don't see any rights or any impulses in there. It's just driven values. As this moves around, there's nothing keeping this in sync between different clients, so they will all end up seeing this red cube in completely different positions. It just gets out of sync. And again, that only happens if you have a feedback loop where the drive is being modified, based on something within the same object or a similar situation. If it was just moving to a global position, it would be fine. So that's why you need to know the difference between drives and rights. If you try to build a vehicle based on this concept, it will work fine if you're the only one in the world. It's a single user thing, but as soon as you get into a multi-user situation, it's a divergent drive, divergent feedback loop in your drives, and everyone will end up seeing something different. Now, if you use rights, the rights will synchronize, so you don't have to worry about them diverging even if you have them in a feedback loop like this.